Okay, so let's break this down into what I consider just a simple chart. I like this chart a lot and I use it quite a bit. In fact, it's not uncommon for me to have this chart sitting on my desk so I can just quickly and easily follow the row and the column and say, okay, we're going to use this analysis, look at it, see that these two variables are this and this is why. Let's walk through this right quick. All right, let's say that your two variables are both dichotomous. Today we're going to talk about phi. We're not going to talk about chi-square and Fisher's exact because we've got a whole other module on those somewhere in the range of modules 8, 9, or 10. Let's say you've got two variables, one's nominal, no order implied in nominal, right? Something like race, and dichotomous, an answer to a question that's yes, no. If you've got nominal and dichotomous data, then you're going to use eta squared. Let's say you've got ordinal and dichotomous data. Ordinal is order implied, right? Like the age example I showed you earlier. So are you a member of 4-H? Yes or no? And what is your age? We'll use rank by serial to see if there's a relationship between those two variables. The dichotomous and continuous question is a little bit harder to understand. Continuous is what it is. You've got a continuous variable like age, or let's say you've got a mean score for a latent construct, or you've got years of service. I mean, there's several different continuous variables that you could name. That's your continuous variable. The question is about your dichotomous variable. Is it a discrete dichotomous or a continuous dichotomous? Discrete dichotomous is easy to understand. Let me give you 3 examples. If the answer to a question is yes or no, it's discrete. If the answer to the question is male or female, it is discrete. If the answer to a question is true or false, it is discrete. Pretty simple, right? Now let's talk about the question of a continuous dichotomous variable. And I'll give you an example from something that we're going to look at in a minute on study objectives. Let's say that you've got a person's weight and you use that weight to classify them into weight status, underweight, normal weight, or overweight. And what you're really just interested in is underweight and overweight. So you removed all the people who were normal weight and you're left with 2 responses, underweight or overweight. So everybody's weight was categorized into either underweight 0 or overweight 1. As soon as you took that continuous variable weight and you categorized it into one of 2 buckets, underweight or overweight, you made a continuous dichotomous variable. And so let's say you take that continuous dichotomous variable, underweight or overweight, and you want to know if there's a relationship between that and a person's intention to eat vegetables. A continuous variable, because an intention is a construct that you measure with a series of items, right? Continuous variable, a continuous dichotomous variable in underweight and overweight. Now we're going to use biserial as our correlation of choice. We'll do a couple others of these as we get into study objectives, so you'll get a chance to practice again. All right, now let's talk about ordinal variables. Ordinal and ordinal. If you've got 2 ordinal variables like level of education and let's say level of income, low, medium, and high. So 2 ordinal variables. You can either use Spearman's rho or Kendall's tau. Let's say you have an ordinal variable and a continuous variable, level of education and attitude toward the environment, Spearman's rho. And then back to our continuous variable and continuous variable. Let's just say this time it is age and attitude toward the environment, Pearson's R. So those are all the different correlation coefficients. And when you break them down into the types of variables you have, to me it makes it just so much easier to make a choice of, or to remember which is the correct choice for correlation coefficient to use. Okay, now on to study objectives.